Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. How are you today? Okay, so hopefully everyone is in a good health. Okay, so actually before you can watch this video here, make sure you watch part 1 and also part 2 first. Okay, if you miss the video, so please check the link in the description down below. Okay, so in part 2, okay, in the previous video, in the last video, we talked about simple system with 100% recirculated air. Okay, I also mentioned about on how to calculate the sensible heat and also latent heat. Where when we want to calculate sensible, we need to use the temperature difference before and after. Okay. For latent heat, we need to use the humidity ratio difference before and after. Okay. So here we want to focus on two separate parts. Okay. The room and also the cooling coil. Okay. So the sensible heat of the cooling coil here, okay, is calculated using this one, this equation and temperature difference before and after. Okay. For latent heat, humidity ratio before and after. Okay, so for the room also same. To calculate sensible heat, we use the temperature difference before and after. Latent heat, humidity ratio before and after. Okay, so this is the concept. Okay, I've talked about this one. Okay, so today let's look at this one. Simple system with outdoor air for ventilation where the bypass is equals to 0. Okay, what does it mean by bypass equals to 0? So bypass here actually represents the amount of air that is being cooled down by this cooling coil. So if the bypass is equals to 0, means that 100% of the air is being cooled down by this cooling coil. So what happened to the air is that the temperature of the air that is leaving this cooling coil here is totally same with the temperature of this cooling coil. Okay, so the temperature of this cooling coil here represents by this one, apparatus dew point. This one, apparatus dew point here is this cooling coil. So in this situation, apparatus dew point temperature is equals to Ts. So which is the supplied temperature. Okay, this one. Okay, so Ts is this one. Okay, so Ts here, this one is wrong. So this one will be Ts. So the temperature that is supplied to this room here. Okay, the flow temperature lah. The flow temperature is Ts here. Okay, so look at this situation here. Okay, so here we have system with outdoor air for ventilation. So means that we have this one also. Okay, we have an outdoor air. Okay, so this outdoor air here will be mixed together with the air from the inside of this room here. Okay, so if you look at this flow here, okay, the air that is leaving this room here will be separated into two parts. Okay, the first part will be released to the environment. Another part will be this one will be moving back to this cycle here. Okay, so this part and also the part from the outside will be mixed together. Okay, and then we will have a mixture. Okay, this one. Okay, so the mass flow rate of a mixture, this one. Okay, will be flowed through this cooling coil. Okay, and it will be cooled down until the mixture temperature becomes Ts. Okay, and will be supplied to this room. Okay, and then the cycle will continue over and over again. Okay, so when we want to calculate the sensible heat of this cooling coil here, as I mentioned earlier, we need to use the temperature before and after the cooling coil. So before the cooling coil, the temperature is Tm. Okay, means that mixture, the mixture temperature. Okay, so which is why, if you look at this equation here, okay, to calculate sensible heat of the cooling coil, we use Tm minus Ts. Okay, so same with latent heat, we use humidity ratio Wm minus Ws. Okay, so the total heat of the cooling coil here is sensible plus latent. So it is QSC plus QLC. Yeah, sensible plus latent. Or we can also use this one. Okay, the difference in enthalpy. Okay, before and after also we can use this one. Okay, and we have okay, so previously we have this one here, room sensible heat factor. Okay, for this one here we have coil sensible heat factor. So means that we want to find this one, the coil sensible heat factor here. So because the words sensible means that we need to relate sensible heat, okay, and also the total heat. So this one here is sensible heat over the total heat of this cooling coil. Okay, so I already mentioned about bypass is equals to 0. Okay, so this bypass here, we can calculate it using this equation. Okay, this bypass factor. Okay, so bypass factor here, if we see here, Ts minus TADP. So Ts is this one, the supply temperature here. TADP is this one. Okay, apparatus dew point means that the temperature of this cooling coil. Okay, TBC. What is TBC? So BC here, okay, is actually before coil. Okay, BC is before coil. Okay, why I put BC? Why I didn't put TM? Okay, this one is TM. Why I put BC? Because we can have a lot of situation. Okay, so the air before entering cooling coil can be a mixture air, outside and inside. Can also be 100% of air from the inside. Can also be 100% of the air from the outside. Okay, it can be anything. So it did not totally fix to mixture only. No, so which is why I put TBC before coil. Okay, clear? Okay, so the bypass factor, when you calculate, it will become 0.1, 0.2, 0.3. Okay, so that is the value of bypass factor. Okay, and to calculate the mass flow rate, MS. Okay, the mass flow rate here actually relates to this one, okay, MS. Okay, so MS, this one, MS, So to calculate this one, we can use the sensible heat of the coil, this one, over this one here, specific heat, 1.0216 here, multiply with TBC minus TADP, and then multiply with 1 minus X. This one. Okay. So why we have to use this equation? If you look at this equation here, okay, compared to this equation, okay, QSC here. So QSC here, we need to find this one, TS. Okay, we need to find TS to calculate MS. So here, if we know the temperature of TBC, we know the temperature of TADP, and we know the bypass factor here, this one. So no need for us to find TS. Okay, we can use this equation to calculate the supplied mass flow rate. Okay, and the ratio between outside air and also mass flow rate, okay, can be calculated using these three equations. Okay, this one, this one is humidity ratio, this one is specific enthalpy, and this one is temperature. Okay, so somehow, because okay, we have this symbol here, means that it is not totally 100% accurate, okay, when you calculate. But somehow we can use this one also. Okay, but it is I prefer to use this one, okay, humidity ratio and also specific heat, okay, rather than temperature. Okay, So, that's it for the system with outdoor air for ventilation where the bypass is equals to 0. So in the next video, I will show you the situation when the bypass is more than 0. Okay? Okay, so see you again in the next video. Bye bye.